We are going to do the video for 11.3, surface area of pyramids and cones. So the first thing we need to talk about is what pyramids are and what cones are. It's going to be very related to 11.2, where we had a lateral area and a base area, and adding that up to get a surface area. The difference with a pyramid is that there's not two bases, now there's only one base. So you have any shape, any polygon on the bottom, and then just a point up top called the vertex. So a pyramid is a polyhedron in which one face, the face is called the bottom face is called the base. That can be any polygon, and the other faces are called lateral faces, are triangles. So yesterday all the lateral sides were rectangles. Now we have triangles. You name a pyramid by the shape of its base. So this would be called a hexagonal pyramid. The altitude is the perpendicular segment from the vertex straight down the middle. So this is the altitude, this is the height of the pyramid, which is different than what we need today. So that's called the altitude. We want something a little bit different, which we'll talk about in just a second. So that's going to be like h, that's the length of the altitude. Okay. A regular pyramid is a pyramid whose base is a regular polygon, and then all the triangles are going to be the same size, isosceles. The slant height is going to be something a little bit better for us today, which we'll talk about in a second. But what we need to know is, we don't need to know how tall the pyramid is today. That's a volume thing. What we need to know is how long or how tall is the triangle. So that's called a slanted height, and we use a cursive L for that. So we need to know what the slant height is today because we need lateral area. Instead of an area inside, we need an area outside on the surface. So in the book, in our worksheets, you can assume that a pyramid is regular unless stated otherwise. So what we're going to look at then is a couple formulas here. All right. Yesterday we had LA plus 2B. Notice how that is turned into LA plus B, because on a pyramid there's only one B. There's only one base. All right. The thing that's different with our lateral area, it was perimeter times height yesterday. There's a couple changes. We have, instead of just perimeter times height, we have 1/2 perimeter times height because we have triangles. This is going to give you the area of the triangular sides. And then the capital B will be whatever the bottom is. Okay? And then the other difference is that cursive L, remember that means slant height. We need to know the slant height in order to know the area of the triangles, because that slanted height is going to be the height of the triangle. So we can do 1/2 base times height. So let's try a couple. We're going to find the surface area of a pyramid. So this first one's a little tough because it's a hexagon, so we have to remember the formula for capital B or big B, which we'll talk about in a second. All right, but what we have here for surface area is it's some lateral area total plus the area of the only base that we have, which is capital B. To find the lateral area, we do 1/2 the perimeter times the slanted height. And to find the capital B, we'll get back to that in a second. For this one, we are given L, which is 9. The perimeter has to do with the side length. There are 6 sides that are all 6 inches long, so the perimeter of this one is 36 inches. So if I'm going to go to do the lateral area, then I have 1/2 the perimeter, which is 36, and the slanted height, which is 9. So when you do all of that, you end up with 162 for that lateral area, square inches. Okay, so we're going to circle that one. We're going to come back to that later. We need that number. For the capital B, we are going to do the formula for the regular polygon, which is 1/2 ASN. So to do that, 1/2 ASN, we need A, which from the picture is 3 square root of 3. That's this perpendicular distance to the center. The side length, which is 6. The number of sides of the bottom, which is 6. So I have 1/2 times 3 square root of 3 times 36, essentially. Again, you could use just the perimeter for that part. It's about 93.531. So I'm going to circle that one. We have our two numbers that we need. To get our final answer then, our lateral area is 162. Our capital B, our big B, is 93.531. So if I add those up together, I get about 255.531 square inches. It doesn't say how we're supposed to round this time, so that nearest thousandth will have to be okay. We're going to try that again with a square pyramid. That actually might go a little bit better because we don't have to do the 1/2 ASN idea. So it's going to be that same process to find the area of this square pyramid. In order to answer surface area, we need the lateral area and the area of the bottom or the base of the pyramid. I shouldn't always say bottom, I suppose. So for LA, we have 1/2 the perimeter times the slanted height. We'll see if they gave us everything we need there. The slanted height is 6 this time. They do show that that goes from the vertex to the bottom of that side of the triangle. Okay, so I know that the slanted height is 6. The perimeter, if one of these sides is 5, there's 4 sides that are all that same length, so 5 times 4, or the perimeter is 20, so I'm going to put a 20 in here. So 1/2 times 20 times 6, you should get 60 square meters. Then I'm going to go and do the area of the base, capital B. This is a square. You could square the side length, or you could do base times height. So the base and the height of this square bottom will be 5 and 5, either way. So I have 25 square centimeters for capital B. Meaning I can get my final answer with surface area. The lateral area was 60. The area of the base was 25. So I have 85 square meters for my surface area. That's if everything is nice and set up for you. It does get a little bit trickier sometimes with our situations where we do not have the lateral height. They're giving us the altitude height, which can be a problem. So we're going to try a couple like that. This says find the LA and SA of the pyramid, lateral area and surface area. Round the answer to the nearest 10. So the surface area is going to be the same setup, LA plus B. It's just that if you notice, they give us a weird height. They give us the altitude. They gave us H instead of L. So they didn't give us this L yet. We need to find that. All right, so for LA, that makes it tricky right away. We have 1/2 the perimeter times the slant height. I do know that the perimeter can be found. If this is 30 here, there's 4 sides that are all like that, so 120 would be that perimeter. So I can plug that part in. The slant height is what I need to find now. So to get the slant height, we're going to use this right triangle. They gave me this H. So I know that this is the very center of the base, which means if the entire base length is 30, then this is half, or 15. So what I have is 2 of the 3 sides of a right triangle. If you're missing the slant height, it's going to be Pythagorean Theorem. A squared plus B squared equals C squared. So over here, I'm going to write that. We need to find the slant height. So actually, instead of C squared, I'm going to write cursive L squared for slant height. So we'll have everything we need. So I could use 36.4 squared and 15 squared to give us L squared. So if you go to plug that in, you get about 549.96 once you add them together. So we're going to take the square root of that and end up with our slanted height. So this time our slanted height is about 39.37. Alright? So if our slant height is 39.37, I'm going to write that again, just so it's a little bit easier to read. We just found that L is that 39.37. So that's this height, the one that we want. So that's what I'm going to put right in here, 39.37. Now I can get that lateral area. So the lateral area then is 1/2 times 120 times 39.37, so about 2,362.2 square meters. Hold on to that number. The capital B is just 30 times 30 this time, base times height, so 900. Hold on to that number. We can add those two up to get our final answer. So our lateral area was 2,362.2. Our big B was 900, which means if I add those together, I get 3,262.2 square meters to the nearest tenth for my surface area for my final answer. All right, we'll try that one more time, and then we're going to switch our conversation to cones at that point. So with this one, we do have a hexagonal pyramid again, which means we have 1/2 ASN for capital B. But before we even get that far, we need LA plus B. And for this one, we have the same problem. The lateral area is 1/2 times the perimeter times the slanted height. I can get the perimeter. Each side is 36. There are 6 sides that big, so the perimeter is 216. So I do know that the perimeter is 216 this time. I do have the wrong height again. So I have 42, which goes from the top, from the vertex, straight down into inside the pyramid, which is an H. So I have to use Pythagorean Theorem to get L. I'm missing L again. So let's find that. Let's figure that out. So for L, it's going to be a squared plus b squared equals c squared. They gave me this length, 18 square root of 3, because that's my apothem for later. So I can go right into the Pythagorean Theorem then. Let me write it right down here. So what I can do to find L is I know that 42 squared plus 18 square root of 3 squared, let me put that in parentheses, equals L squared. What we end up with then is 2,736 equal to L squared once you punch that in. So I can take the square root of both sides to get my slanted height of 52.307 this time. So I needed that number. That's my slanted height. That can be what goes in here, 52.307. All right, and now I'm ready to find the lateral area by plugging that in. 1/2 times 216 times 52.307 would give you about 5,649.156. So that's my LA answer. Capital B is 1/2 ASN because it's a regular polygon again. 1/2 ASN. I do have that A was 18 square root of 3. I do have the side length of 36. I do know that it's a hexagon that has 6 sides. So that big B is going to give us about 3,367.106 for my capital B. So that means I'm ready to get my final answer. So it'll be a little bit of a larger answer this time. 5,649.156 plus 3,367.106 gives you about 9,016.262. They did ask us to round to the nearest square, it should say square foot, but to the nearest square unit. So I'm going to round that back down. I'm going to call it 9,016 square feet for my surface area. So that's going to be everything you need to know about pyramids. If you don't know the slanted height, you have to use Pythagorean Theorem to get it. Otherwise, it's LA plus B, and where that LA is 1/2 times the perimeter times that slanted height. The next video is going to go over cones. That's that part 2. So go ahead and switch to that video now.